Yeah, good evening, everyone. So, in this today's session, we are going to start another new concept. Okay, almost tree data structure is there. So, we are going to discuss about that tree data structure in this today's tree data structure in Python. How to implement this tree data structure, we will discuss. So the concepts which we are going to cover here is introduction to tree data structure, introduction part, and terminologies. We are going to use some terminologies in tree. Okay, terminology in tree. There are some terms will be there, so that we are going to discuss next. And after that, binary tree in short form it is called as a BT. Then binary search tree will be there, okay, which is called as a BST. Then we are going to talk about AVL trees. It is nothing but height balanced tree. So these are the topics which we are going to cover. Sir, these things we are going to get a big programs. Okay, once if you understand the tree terminology, everything will become easy for you. Let me give the definition, all these things, introduction part, everything. So to execute these programs, I am taking the command prompt. So now I am going to define this tree. How you can able to define a tree? If we want to represent, if we want to represent the data in the form of, if you want to represent the data in the form of hierarchical, okay, hierarchical relationship. If you want to represent the data in hierarchical representation, then we have to go for this tree data structure. And please make sure it is non-linear. It is non-linear data structure. It is nothing but what? Non-linear data structure. Here there will be one relationship called parent and child relationship will be there. Means what? The nodes which are available at the top is called as parents, and the nodes which are attached to that are called as what? Children or child. Like that it will be there. Then, sir, where we are going to use these data structures? It is best suitable. It is best suitable for search algorithms. Best example for this, I think already we know, we have seen binary search implementation. How binary search is going to work? We are always going to perform this search operation at a very top level. So first we are going to compare with the root node, and if it is matched with the root node, the result is successful. If it is not matched with the root node, it may be available in the left side, or it may be available in the right side. It is something like a binary search algorithm. Okay, so you know, in the linear search, if you implement, we are going to get a big O of n time complexity. Same thing if you take binary search operation, it is going to take a big O of log n. Like that, there is a small change is there. That is the reason why we are going for tree data structure. And here, what is the exact definition of a tree means? So tree is a finite set of one or more nodes. Okay, one or more nodes, such that such that how you are going to define the tree? So it is nothing but a collection of one or more nodes, such that there is a specially designed node will be there, which is called as root node. There is one specially designed node will be there, which is called as root node. And remaining nodes, okay, remaining nodes are so partitioned into n greater than or equal to 0. So subsets or subtrees, like that we can take. Okay, so here if you want, diagrammatically I will represent, which is nothing but a tree. For example, if I am taking like this, only one node I am going to represent like this. So let us consider this is nothing but n0, 0th node. Is it a tree means? Yes, it is a tree. If you are taking n0 here, and I am going to take only one child for this, so is it a tree means? Yes, it is a tree. So I have n0, one node is there, and for this one node is attached, which is nothing but n1, another node is attached, which is nothing but n2. Is it a tree? Means yes, it is also tree. Suppose consider I have n0 node is there. For this I am going to attach n1. So for this I am going to attach n2, and for this I am going to attach n3. Can I take like this? Yes, it is also a tree. So can I take n0 like this, and n1 is attached to this, and n2 is attached to this? For this n1, again I am taking n3 and n4. So for n2 I am taking n5 and n6. Like this we can take. Is it a tree? Means yes. So tree means what? There will be one special node will be there called root node. In all these cases you can see n0 is nothing but root node. Remaining nodes are partitioned into n greater than or equal to 0. In this case, how many subtrees are there? 0. In this case, 1. In this case, 2. In this case, 3. In this case, 1, 2, 3, 4, 5, 6. Like that we have. Okay. This is nothing but the exact definition of tree, and diagrammatically how we can able to represent trees. Okay. So in this, the conclusion is there will be one root node will be there, and any number of children can be attached to that root node. This concept is called as what? Tree data structure. Any doubt up to this? Any doubts up to this? Please confirm everyone.
Sir, N0 also tree.
Sir?
N0 is also a tree.
Yes.
Only N0.
Yes. It is a
Okay.
tree.
Okay.
Which contains how many nodes? Only one node.
Okay. Okay. Sir.
Okay.
Okay.
Right. Next, we are going to see some terms used in this tree data structure. Terminologies. So tree data structure. What is the first terminology that we have is root node. If you take any tree, sir, unique node, it is nothing but a unique node having only outgoing edges. It is nothing but a tree which is having only outgoing nodes. For your understanding purpose, I am taking a tree. Let us consider the root node is nothing but a. For this we have two children are there. Let us take b, c, and then d. Let us take three children, b, c, and then d. And for b we have one children is there, which is nothing but e, and one more child is there called f. And for c only one child is there, nothing but g. Okay, next here we have so h and then I. So then for j, for I, we have one more child is there called j, and then k. Like this we have. So in this, which is the root node? Is it a tree or not? Yes. Which is the root node here is nothing but it is a unique node which is having only outgoing edges. If you take in this diagram, there is only one node is there. The name of the node is nothing but a, which is having only outgoing edges. Outgoing edges means what? From that node, so outgoing will be there, there is no incoming. So I can take example here. A is nothing but what? Root node. Okay, a is nothing but what? Root node. Now what is this node? How you can able to represent the node? So we can represent the node, okay, like this. It is nothing but, so fundamental, it is nothing but a fundamental element of a tree. Okay, it is nothing but fundamental of a tree. So each node contains the following three fields. Sir, generally I think you can see like single linked list, double linked list, like that, right? If you take single linked list, we are going to take only two fields. One is nothing but a data field, another one is nothing but next field. One second. So it is nothing but a fundamental element of the tree. Each node contains how many fields, sir? Three fields will be there. In the case of a single node, we are going to take two fields, right? Data field, next field. If you take double node, three fields will be there. One is pointing to the left child, another one, sorry, one is pointing to the previous node, another one is pointing to the next node. So here this node is going to have three fields. What is the first field is nothing but data field. Okay, what is the first field is nothing but what? Data field, where it is going to take the actual content. Next one is nothing but left pointer, left pointer. So pointing, okay, left pointer pointing to the left child. So then another pointer will be there, so which is nothing but right pointer. Okay, right pointer, so pointing to the right child. But of course, if you take this diagram, for a, how many children are there? Three children. That means for a, we have to create a node like this, not three fields. We have to take four fields like this. Maybe if it is representing the data field, this one is pointing to which node? B. And this one is pointing to which node? C. This one is pointing to which node? D. There is no limitation. That's why this tree, which is nothing but a normal tree, we can represent always theoretically, but we can't implement the program. That's why to overcome these problems, we are going for binary tree. But anyway, I will explain in detail about that. So as of now, I have taken only two terms related to the tree. The first one is nothing but what is mean by root and what is mean by node. Root means what? The top level element is always called as a root, which is not having any incoming edges, only outgoing edges will be there. And node means what? It is nothing but for programming purpose, every tree element we are going to represent by using node. Generally it is going to have three fields. One is pointing to the left child, another one is pointing to the right child, and the middle one which is always pointing to the content. Are you clear with these two terms? Please confirm. Right. The next one, from here you need to put more concentration. Listen carefully. The next one what we have here is, I'm going to talk about edges. I'm going to talk about edges. Sir, what is mean by edges? It is also called as, it is also called as fundamental. Okay, fundamental part of a tree. So use it to connect two nodes. If I want to connect two nodes, then we have to go for the concept of edges. In this tree, which are edges? Sir, A to B there is a connection, right? It is an edge. A to C, is there any connection? Yes, it is a edge. A to D is the edge. B to E is the edge. B to F is the edge. C to G is nothing but edge. D to H is the edge. D to I is the edge. And then I to J is the edge. I to K is also edge. These are called as what? Edges. I think you people got a very clear clarity. There is one more term is there called path. What is mean by path? An ordered, okay, an ordered list of nodes, an ordered list of nodes. So that are connected by edges, that are connected by edges are called as path. Sir, can I say A to I or A to J? Is there any path is there or not? Yes. First we have to travel from A to D, then we have to travel from D to I, then we have to travel from I to J. This is called as what? Path. Path means what? It is nothing but ordered list of nodes from one point to another point. And there is one more term is there called leaf nodes. Leaf nodes. Sir, all these are from A to K, everything is a node or not? Yes. But in that, A is always called as root node. What about leaf node? Sir, here the nodes which are not having any children, not having any children, are called as leaf nodes. The nodes which are not having any children are called as leaf nodes. That is nothing but what? Can I use the word called edges? Yes. Best example. Okay, best example. Can I say E is a leaf node? Yes, because it is not having any outgoing edges, children. Sir, F, it is a leaf node. G, it is a leaf node. Sir, H, it is the leaf node. Is I is a leaf node? No, because it is having two children. J is the leaf node, and at last K is the leaf node. These are nothing but what? Leaf nodes what we have. So everyone, please confirm. Edge means what? Path means what? Leaf node means what? Is it clear? Yes, please confirm everyone. Clear? Right. So the next term what we have here is we need to calculate height of the tree. So what is mean by height of the tree? All these are theoretical part, sir. You may get bored. Okay. Sir, what is mean by height? So height of the tree. Okay, height of the tree is a sum of edges on the longest path between root and leaf. Root and leaf, you have to find out so longest path between root to leaf. Sir, A to E one path is there, so A to F one path is there, A to G one path is there, okay, A to J one path is there, okay, so A to K one path is there. Sir, A to E, how many edges are there? We have two edges are there, two edges are there, okay. Sir, A to F, how many edges are there? Two edges are there. A to G, how many edges are there? Two edges. A to J, one, two, three edges are there. A to K, three edges are there. So, what is the height of the tree? The height of this particular tree is nothing but what? Three. Maximum. Maximum edges what we have, that path is there, right? So, how many edges will be there, that we have to count. So next terminology, sir, we have one more word is there called level of the tree, level of the tree. So what is mean by level? Means the level of a node or tree. The node or tree is a number of edges on the path from root to that node, root to that node. For example, if you take the node A, sir, it is at which level? 0th level, because there is no 0 edges to A, right? If you take B, C, D, okay, these are at level 1. If you take E, F, G, H, I, these are at level 2 because two edges are there. If you take J and K, these are having three levels. Okay, like this level means what? From 0 we have to count. So all the nodes which are present in that particular number of edges is nothing but we can count it as a level of the tree. Next, one more term is there. This we know already, parent. What is mean by parent? Here, a node is parent of all the children. So that are linked by outgoing edges. Outgoing edges. If anything is linked by using outgoing edges, then it is called as a parent. Sir, is A is having a linked with outgoing edges? Yes, it is the parent. B is the parent. C is the parent. D is the parent. So E is not a parent. Why? Because E is not having any children. So F is also not a parent. Okay. And G is also not parent. H is not parent, but I is the parent. Like that we have. So what about the child? Child means what? The nodes. Okay, the nodes. So that are having incoming edges are called as children, which are having incoming edges. If you take a B is a child, so C is the child. Next and after that D is the child. So is E is a child? Yes. F is the child. G is the child. H is the child. I is the child. J is the child. So K is the child. Like that we can define. I think what is mean by level, what is mean by height, what is mean by parent and child, these things are very clear for you people. Any doubt up to this whatever I covered? Clear? Please confirm. Right. So the next word what we have here is siblings. What is mean by siblings? Very simple. The nodes in the tree, the nodes in the tree that are children, that are children of same parent are called as, are called as siblings. That means what? The nodes in the tree which are children of same parent. Can I say B, C, D are siblings, right? Because same parents are there. Similarly, can I say E and F are siblings because same parents are there? Like that, for one or more nodes, if it is having same parent, we can call it as a sibling. Then the next terminology here is nothing but, sir, we have ancestor is there. So what is mean by ancestor? Very simple. A node which is reachable, a node which is reachable, which is reachable through repeated moving from child to parent. That means if you take any node, maybe I am taking J. Sir, what are the ancestors for J? Who is the parent of J? I is the ancestor. Who is the parent of I? D. D is also ancestor. Who is the parent of D? A. So like J, I, D, A. So for J, I, D, A, these three nodes are nothing but what? Ancestors. Like this we have. Sir, up to this, do you have any doubts about this siblings and ancestor? Do you have any doubts? Please confirm. Right. Last two words. Predecessor is there. Predecessor means while displaying, okay, while displaying or traversing the nodes in the tree, okay, the nodes in the tree, while displaying the nodes in the tree, if a node comes before another node, is called as predecessor, is called as what? Predecessor. Example, sir, I can say E is predecessor. E is nothing but a predecessor of the node I. E is nothing but better I will take which part. Second, I will change the color. If you take B, E, F, these three nodes you can consider. We are getting first E and then B and then F, right? So here I can say predecessor means what? Sir, for B, for the node B, okay. So E is predecessor. E is nothing but predecessor for B, sir. Like that we have. Opposite for this is nothing but a successor. What is mean by successor? While displaying the elements, while displaying the nodes in the tree, while displaying the nodes in the tree, if any node comes after another node, then it is called as what? Successor. So here F is nothing but, F is nothing but a successor of B. That means while displaying that small part like E, B, F, so E is going to come before B, right? Then B is for B, E is called as what? Predecessor. F is called as what? A successor. Like that we have. So are you clear with this? All the terminologies related to the tree, please confirm. Because in the implementation, we are going to use all these terms. Any doubts? Please confirm everyone. Clear? Predecessor and successor in the in order, I mean, while implementing the program, I will explain in detail, Pranay. But as of now, remember, if you have any tree, If you take any tree, here I highlighted with black color, right? B is the parent node, E and F are nothing but children. Generally, how we are going to read this tree in the sense E, B, F, like that we will take. Okay, first left child, then root node, then right child. In such cases, for B, which is a previous E, then it is called as predecessor. So what is the next node for that? F. F is the successor for B. Got it? Don't worry. In detail we will discuss. Right. So with this, the introduction part, tree related terminologies got over. Now we have to talk about implementation. Very, very important thing. But we can't implement this tree directly. That's why I will start the topic called binary tree. What is mean by binary tree? We will see the implementation of this binary tree. What is mean by binary tree? Binary tree is a type of tree. Binary tree is a type of tree in which each node has, so at most each node has at most two children. At most two children means what? Either 0 or 1 or 2 children should be there. Okay. So which are referred, okay, which are referred as left child, okay, and right child, which are referred as left child and then right child. So in binary tree, each node will have data field. Already we discussed about this, and two pointer fields will be there. Two pointer fields. So what are those two pointer fields? One is a pointing to the left subtree, another one is pointing to the right subtree. Like we have to take two pointers. Sir, directly I will go with the implementation. Binary tree implementation. We can implement this binary tree in two ways. One is nothing but sequential. Okay, sequential representation. We can represent this binary tree in sequential representation, or we can go for linked list representation. So in how many ways we can represent this binary tree? There are two ways are there. One is nothing but what? Sequential representation. Another one is nothing but what? Linked list representation. Like that, there are two ways are there. Okay, let us go for first one. What is the first one here? Sequential representation. Directly I will take the program, but before moving to the program, there is one small formula is there in this sequential representation. Suppose consider I want to take a tree. Listen carefully this diagram. I want to take a tree. So where one is nothing but the root node. Okay, for this I am taking 2 as the left child, and I am taking 3 as the right child. Only two children should be there, not more than two. Maybe 0 children is okay, 1 children is okay. So 2 children is okay, but more than 2 is not allowed. For 2, I am taking one more child, which is nothing but 4. And then here I am taking 5. And here I am going to take 6. And here we are going to take 7. So like that. So total, how many nodes are there here? 3 plus 4, 7 nodes are there. Okay, I want to represent this. Sir, we can take a list to represent this. How you can represent? 1 2 3 directly, sir. 1 followed by 2 followed by 3 4 5 6 7, like that. If you see, this one is available at 0th location, first location, second location, third location, fourth location, fifth location, and sixth location. Means what? These 0 1 2 3 are representing the position value. Sir, maybe consider this is 0th position, first position, second position, third position, fourth position, fifth position. Now if you take any node, we can able to identify left child and then right child. Consider parent is available at nth position. Okay, what about its left child? Its left child is available in which position? Means there is a formula 2n plus 1 we have to take. Okay, If you take a parent node which is available at nth location, its left child is available in 2n plus 1. So its right child is available in, okay, 2n plus 2. Like this, we have a formula. If you want, if you take n is equal to 0, that means I'm talking about the root node which is nothing but 1. For 1 which is the left child, we have a formula. So 2 into n plus 1. Since n is equal to 0, so 2 into 0 plus 1. 2 into 0 means 0 plus 1. Means what? 1. In first location, which node is there? Which is nothing but 2. 2 is nothing but left child for 1. Similarly, for this, how to identify the right child? Sir, 2n plus 2. That is nothing but 2 into 0 plus 2, which is nothing but 0 plus 2, where you are going to get output as a 2. So in second location, which element is there? 3. That 3 will become right child for the node n is equal to 0. I think you people got very clear clarity how sequentially the data is represented. Okay. Any doubt about this linked list representation of this sequential? Yes, please confirm. Right. If you want one more example, I will take n is equal to 2. That means for node 2, that is nothing but what? Node 2 means what? 3. 3 is nothing but its data. What is the left node, left child of 3? How you can get 2 into n plus 1? So 2 into n value is nothing but what? 2 plus 1. So 4 plus 1, which is nothing but 5. In fifth location, which data available? 6. Then I want to calculate right side node of 3. What about that one? 2 into n plus 2, which is nothing but 2 into 2 plus 2 we are going to take, which is nothing but 4 plus 2. Sir, the output is nothing but 6. In sixth location, which element is available? 7. Like that we have. Okay. So now we are going for the second approach. What is the second approach here? Second approach is nothing but linked list representation. So we can represent binary tree by using double linked list. But don't worry, in the program directly I will explain, because there is no formulas, directly we can represent. Please confirm how to represent this binary tree. Is the concept is clear for everyone? Yes, please confirm. Right. But if you want to view the content, compulsory we need to display the elements present in the linked list. So how to display the elements in the linked list means what? For that we have traversal techniques are there, binary tree traversals are there. So whether you are implementing binary tree or binary search tree or AVL tree or any tree, but so these traversals are nothing but same. Sir, traversing means what? So traversing means visiting, visiting each node once in a tree. Okay, we are going to visit each and every node one time in a tree. Okay, so it is also called as, okay, displaying, something like that. We may use the word called displaying. Okay, so the following are the three ways or three methods existed for traversal operation. So what are those three methods? The first one is nothing but in order traversal, where first we will focus on the left subtree, then root node, and then right subtree. And we have pre-order is there. In the pre-order, first we are going to focus on root node, then left child, and then right child will be there. Then we are going to see post-order traversals. In the post-order traversals, first we are going to focus on left child, and then we are going to focus on right child, and at last we will give priority to the root. Like that we have. Sir, I will take some examples, then only you can able to understand well. Sir, consider I will take a tree. For that tree we have to identify in order, and we have to identify pre-order, and we have to identify post order of the tree. So what is the example that I am taking here is simple example. Consider I am going to take, so A is nothing but root node. For this B is nothing but left child, and C is nothing but right child. Like this I am taking. In this case, what is in order? In order is nothing but first we have to visit left child, which is nothing but B. Next we have to visit root, which is nothing but A. Next we have to visit a right child, which is nothing but C. So what about the pre-order? Pre-order means what? First root node. What is a root node? A. Then left child B, then right child C. So what is mean by post order? Sir, post order means what? First left child, then right child. Okay, so then root node. Like that we have. This is nothing but example one what we have. Sir, everyone feeling comfortable up to this, so that I can go for second example. Is the traversing of this tree, is it clear? Right. So what is the second example here is I will take another tree. So here I am going to take, so A, okay. Next and after that, its left child is nothing but a B, and its right child is nothing but a C, D, E. Like this I am taking. That's all. Now listen carefully. What is mean by in order? First we have to focus on left. If you take a tree, which is the root node here, A, what is the left child for this? B, D, E. Again, is it a tree or not? Yes. We have to apply the same principles again for this tree. That means for B, D, E, we have to find out in order. First, what is a left tree, a left subtree in this B, D, E? D. Then root node is B. Then right child is nothing but E. So visiting of left child got completed. Then what is a root node? A. What about right child? C. Like that we have. So pre-order means what? First root node. What is a root node here? A. Then left child. In the left child, again a tree is there. In that, which is the root node? B. Then left child, then right child. Then already root node is completed. Its left child completed, right child is pending. Like that we have to take. What is mean by post order? First left child. If you take the root node called A, what is the left child for that? B. B is again a tree, right? So we have to apply the same principle for this. Who is the left child for B? D will become left child. Then right child E. Then root node B. Okay. For this, so main root node, we completed visiting of left nodes. Then take the root node. Sorry, we have to go for right child, and at last we have to go for root node. Like that we have. Okay, this is nothing but what we have. Another example. Sir, everyone please confirm, is these two examples are clear for you people? Clear? Yeah, yeah, sure. One more example I will take. One big example I am going to take. Listen carefully. So next I am taking last example, example number 3. So I will take one big example, listen carefully. Right, listen friends. So here I'm going to take the root node as a 1. Its left child is 2. Its right child is 3. For 2, left child is a 4. Right child is a 5. For 3, left child is a 6. Right child is a 7. Like this, I have some nodes are there. What is in order for this? We have to calculate. In order means what? First, we have to take which node? We have to take left child. So for 1, left child is this one. Again, we have to apply in order. In order means what? Left root node and then right tree. Now see. So what is the left child for this subtree? 4. Then root node is 2. Then right subtree is 5. So the root node left subtree got completed. Then we have to visit root node, which is nothing but what? 1. Then we have to visit right subtree. What is a right subtree? This one. Is it again a tree or not? In this again, that L root node left subtree right subtree we have to take. So for this, what is a left subtree that we have? 6. Root node is 3, 7. Like this we have to take. And if you take pre-order, first root node 1, then for 2, 4, 5, again root node left child right child. For right child, root node left child right child. For post order, what we have to do? First left child. Again it is a tree. That's why again left child, then right child, at last root. So left child completed. Go to right child. 3, 6, 7. Again in this left child, right child, root node, and at last main root node. Like this we have to see. Sir, a shortcut for this is, in the in order, root will be there in the beginning. Main root will be there in the middle. So in the pre-order, so that root node will be there at the beginning, at very first. In the post order, that root node will be there at the last. This is nothing but what we have another example. Sir, please confirm everyone. Is it clear? Pranay, got it?
Yes, sir. Yes.
So now I will create this binary tree by using linked list. Sorry, by using list I will implement first. I want to create this by using linked normal list. Let us see. I am taking the class. The name of the class that I am going to take it as, okay, b tree binary tree. Sir, I am defining a class called node because everything is represented in the form of a node only, right? I am taking a class called node. Inside this, I'm going to define init method where it is taking self comma data, left pointer will be there, and right pointer also will be there. So here self dot data is equal to data, self dot left will become the left, so self dot right will become right. I am taking. So after this, I am going to define init method. Sir, for which one? For B tree, I am going to define init method. Means whenever you are creating a binary tree, self dot root node will become none. So whenever you are creating an object for binary search tree, binary tree, a root node will be created, which is always pointing to the none. Then I'm going to take one more method called, so create a tree, where it is going to take a list. Self dot root node will become self dot create a tree util function I am going to define, where it will take the list. What is a root node index? 0. With this I am going to create a tree. Create a tree util function is there, which is taking a list and then starting index. But we know how to create, right? Suppose if they have given this list, so 1 2 3 4 5 6 7, like this they are going to take. How to create this list? First, to create util starting index is nothing but what? 0. Then we are going to calculate size attribute, which is nothing but length of the list. So current node will become self dot node of l of start. What is the starting value that we have given? Sir, 0. The node which is available at 0th location, it will create a node like this. What is the data field? Data field is 1. Like this it is going to create. Can I say is it a root node or not? Yes. For this we have to find out left node. How to find out? 2 into start plus 1. How to find out right node? 2 into start plus 2. Sir, what is the left node for this? Left node is nothing but 2 into 0. 0 plus 1 means the element which is available at first location. Right node is nothing but what? The element which is available at second location, like that. Sir, how you can able to check? If the left node value, whatever you calculated, that is index value, if it is less than size, means what? That node is available. In such cases, I am going to take current node dot left field will become self dot. Again, I am calling this create util function by passing list comma left index. Means what? We are creating for this another node with the content as nothing but 2. So the same process whatever we applied for this, it will be continued. Sir, what about right node? For right node also we have to pass the right index, and we have to repeat this process if this condition is not satisfied. So I think better you can check r is less than size. Like this I am going to take. That's all. At last what we have to do? We need to return that current node. This is the way how we can able to insert the elements in the form of a tree. Up to this, do you have any doubts? Please confirm. Right. So now, if you want to display the elements, we have to write in order, right? So DEF, I am taking in order. Okay, in order traversals, we have to pass a self, and self dot in order traversals of utility method we have to define, because directly we can't traverse. So self dot I am passing the root node, and we are going to print one empty line. Why means we will see later. So in order util function I am going to take, which will take self comma the node whatever you have given. Then if that node value is not equal to none, how you are going to print in the in order? First we have to call recursively, is there any left child for that? Is there any left child for that? So we have to check node dot left. Then after that we have to print the current node data. I want to give end is equal to space. Then we have to apply the same technique for right child. Like this it is going to move. So for your understanding purpose, I am taking one simple example. Let us take 1 as the root node, 2 as the left child, 3 as the right child. Node means what? One, right? So in order of node dot left 2. Sir, is 2 is not equal to none? Yes. In order of left, there is no elements, none. There is no elements, none. Then it will print the node data. Okay. So it will print 2, then root node, then right node. So this one is to visit for left subtree. This one is for right subtree. This one is for root node. So we created the binary tree. We implemented in order traversal. If you are clear with this, directly we can run the program by giving a list. Sir, are you clear up to this? Right. So this same 1 2 3 I will give. If you are giving 1 2 3, what output we will get, you can see. So I'm giving list is equal to 1 2 3 1 2 3 like this, only three nodes are there. Obj is equal to, I'm creating a new binary tree, then obj dot we are calling create tree function by passing the list, and in that object I'm going to call in order function I'm going to call. Let us run the program. Py space test dot py. Sir, you can see 2 1 3. Is it the in order? Yes, definitely, because if you take the diagram like 1 2 3, what is the in order? First we have to visit root node, sorry, left child, then root node, then right child. Like that only we are going to get. Let us cross check. 213. Sir, how to print pre-order? How to print pre-order? So what is a pre-order for this? Root node, left child, right child. What is a post order? Left child, right child, root node. Let me check whether it is going to come. But we need to implement, right? We didn't implement it. Let me implement pre-order and post order. In the case of pre-order, what we have to do? In the case of pre-order, we are going to take, so pre-order util, pre-order util, pre-order. First we have to print the node, then we have to go for left child and right child. So what about post order? What about post order? First we have to print left child, then right child, and then root node. So now already in order we checked. Let me check pre-order. Let me check post order. Let us execute. Is it correct? 213 in order, 123 pre-order, 231 post order. Everyone feeling comfortable up to this? Please confirm.
Yes, sir.
Now same thing, previously we constructed one list, right? By taking that I will implement, so that you will get clarity whether this implementation is working fine or not. What is a second example I am taking? So already we have a list is there, right? I think if you remember, how you can take this list, is it something like from this only, right? I'm going to take this list now. So if you change the list, what will happen? So is the expected output is coming or not? 4251. Have you, first let me copy paste. So I'm copy pasting the output. So already we calculated the in order, pre-order, post order for this, which is nothing but example 3. Now cross check with the output whatever we got. So 4251637, 1245367, 4526731, like that. So everyone please confirm, is this traversing techniques are clear for you people? So this is nothing but what we have practice up to this. So tomorrow also we have a class as usual at 6 o'clock. Tomorrow I will explain the complete implementation of binary tree, and even I will cover binary search tree also. Okay, right sir, thank you. I will upload these running notes within few minutes. You can download. Thank you.